Bonjour and welcome to my channel. Today I want to build a device to control the filament on my printer, but first I need to do a little reorganization in my lab. I want to take the printer who's configured to work in that direction to work in that new direction and reuse the tools put in there. So let's do it! I was able to move the printer because I already bought extension cables from the website where I bought my printer. Now that it's done, you can see the new orientation. It leaves more space to work. Now the spool holder that I built is based on the previous one. I'm gonna leave a link in the description. The main idea is to be able to place any spool size and the filament will make it roll. Now this detector is meant to detect if the filament is missing or not, but I want to do something more. I want to have kind of a detector here to allow me to detect if the spool is turning. So it will allow me to detect if the filament is missing or if the head is clogged. And that's the main purpose of that detector. Let's take a look at the spool holder, shall we? First of all, I already had many rods, many stainless steel rods, and I used them as my base. The rod goes through the design from one side to the other. And as you can see here, I have many plastic pieces. Let's remove one of them just to see the inside. If I hide this one, you see here ball bearings. I have many ball bearings going through because I want to support the weight of the spool. I don't know if it was too much, but anyway, I have a drawer full of ball bearings, so I use them. I also printed plastic parts that will hold the ball bearings to the good distance. So there is a plastic part everywhere inside the spools. Why do I have two main rollers? The idea is to accommodate spools no matter the size of the spool. So here we have a medium-sized spool, but if I have a smaller one, it's gonna fit between the two rollers. And if I have a 2 kilo spool, it's gonna fit there too. So it's designed to accommodate any spool size. I did not want to create a version with a pole going through it because of the detector. I wanted to be able to make the spool turn the detector, and this was, I think, the only option that I had. Now if I show you the rest, this is the plank, the plywood plank that I installed on the top of my printer, and I have an electronic circuit that is going to sit right here connected to the two small boards and allowing me to detect if the spool is turning or not. As I said, the idea is to check if the spool is still turning. If it's not turning, it may be for one of the two following reasons. Reason number one, the print head is clogged, and the reason number two is the filament is empty. For these two reasons, the spool will stop turning, the detector will stop moving, and I will detect it. And based on that detection, I'll be able to pause the printer, allowing me to intervene. Now let's take a look at the detector. If I just show you this part here, the first version that you saw in the video was a wheel with holes in it, but I decided to build a rotary encoder, so I replaced it by a wheel with teeth. And the idea is to block the light passing through these two holes. The teeth are just large enough to block one or two of the light sources at the same time. The idea of that plastic block is to hold two LEDs on one side and two light detectors on the other side. Then in Fusion I designed two small boards that will be placed on each side and will accommodate me to solder the LEDs on one side and the light detector on the other side. Okay, so that's the main idea of my spool holder. So now let's take a look at the electronic circuit that I made for that project. As you can see, I use a WeMOS, and the reason is I want to post information on the cloud, and this chip allows me to do so. The problem is I don't have more than one analog pin, and the circuit is based on an analog device. Let me show you the pinout. As you can see here, there is only one pin called A0, allowing me to read an analog value, so I wasn't able to use the analog approach. I have to convert the analog value to a digital value. And that's why I use the MCP602, a dual op-amp. First, you can see that I have two different channels. The two channels are identical. So let's check the first one. As you can see, I have my LED here. I have my lie detector that gives me an analog value that I have to convert to a digital value. I calculated that a voltage divider including one 4.5 and one 10K resistor gives me the perfect threshold over which I can flip from 1 to 0 if the detector detects light or not. So I placed a LED here just to give me a feedback if there are any activity. I did it twice for the two channels, and I read the digital values from the pins D5 and D6. I also prepared a pin for the reset. I'm going to show you why it's important to reset the chip. And I have a transistor to drive a relay. The relay is meant to pause the printer. My printer already have a detector for that. You saw it in the video. And I want to fake the detector using a relay. And the last part is a buzzer. So that's the circuit. Once the circuit was designed, I transfer it in Eagle. So that is the circuit that was transferred in Eagle. Let's take a look at the electronic circuit. This is it, where I have an external part here. I intend to cut two boards on my CNC, this part here and this part here, so I can cut this small chunk of, let's say, PCB with my Dremel and use the two boards as two separate boards. So that's the goal. Now let's go on the CNC and cut the electronic circuit. Okay, now let's have a brief look at the enclosure. First, I'm gonna remove the spools and activate the enclosure. You see the electronic circuit that I designed in Fusion. I added a couple of components just to give me the size of the device itself. I designed the base to support the electronic circuit because of the pins going through. And this is the enclosure. I built this kind of enclosure with I'm gonna put a sticker in front of it to allow me to see the activity using two LEDs, and one of the LED will be used for the Wi-Fi. So the two LEDs here will blink when the rotary encoder blocks one or the other LED. The Wi-Fi LED is connected to the built-in LED on the WeMOS board and will blink when it detects the DHCP and goes solid when the network is connected. And I have the reset button right here. The reset is used when I push it. It's going to reboot the WeMOS, and as I boot the WeMOS, just after finding the Wi-Fi network, my device posts 4 zeros and 4 100s. So it gives me a graphic that represents the start of the capture of the activity. I'm going to show you it in action in a few seconds. So this is it. Let's print it and sand it, paint it, and install it. Let's do it. First, let's remove the actual detector and replace it by the tooth version with my rotary encoder design. Okay, now we can clearly see the rotary encoder blocking the holes, so blocking the lights of the detectors, as you can see here. It's working as expected. Okay, I started the print, and why not? I decided to test my circuit to make sure it works correctly, and because the electronic is all installed, everything is plugged, it is monitoring actually the printing, and as you can see we have movement on the spool exactly as expected. And I already did a couple of tests stopping the spool just to see the behavior of the electronic, and it works well. It stops the printer as expected. While printing, you can see the graph here. You can see a new value coming in a few seconds. Here we are. We have the new value. So from a distance, I can monitor that the printer is still working, and that's great. The printer is connected through this wire, and the relay will pause the controller if there is any problem, a clog or no more plastic in the spool. So I'm very comfortable now to make larger prints. Now that the print is finished, I had to sand and patch some holes because the print wasn't perfect, and then I painted it orange. This was the only color I had on their hand, so let's see it. Okay, let's test it. Let's power it on. Let's plug it. As soon as it's plugged, you're gonna see a fast blink of the Wi-Fi indicating that the HEP is waiting to get the IP address. When it gets the IP address, it posts a couple of zeros and ones to create a spike in a graph, as you can see here. And from that point, it starts monitoring the movement of the spool by using the activity LEDs here. If I want to change the delay before it beeps, I can change it from the website. And the beep you hear is from the enclosure. It's a feedback coming from that device. So when I print, I set it to 600 seconds, so 10 minutes. Okay, the time it takes to heat up the printer. And as soon as it starts printing, activity will occur. Then I can lower the limit to something like 50 seconds. I made a couple of tests, and 50 seconds is a good number. I heard the beep from the device to confirm the order, and from that point on, as soon as the spool moves, it's gonna monitor and stop the printer if the print stops for 50 seconds or so. So this concludes the video for today. I hope you enjoyed it. I hope you learned something. I hope I inspire you. So stay tuned, subscribe, share my video, and see you next time. Bye!